Hi and welcome to Photo IQ. I'm your instructor Gus Cantavaro, and in this unit we're going to be talking all about focal lengths. Let's get started. Okay, let's start with some basics here. The focal length of your lens is the millimeter number that's imprinted on it. Okay, so just like in this lens, this is a 100 millimeter f2 lens by Canon, and you can see circled there on the bottom is 100 millimeters. That is the focal length of the lens. There's going to be zoom lenses which are going to have multiple markings on there, but we're going to get to that in a little while. The viewing angle is the degrees of visibility. Now, by degrees, I mean of a circle. So for example, a 45 degree angle or a 90 degree angle. That is going to be your viewing angle of the lens. Every lens is going to have a unique viewing angle, and it's going to vary by design. So sometimes you can have multiple 50 millimeter lenses made by the same manufacturer with a slightly different viewing angle. And certainly across different brands, so Canon, Nikon, Fujifilm, Sony, they're all going to have slightly different designs, and that's going to have to do with the physical size of the lens and then other characteristics that may have a slightly wider or slightly narrower field of view or viewing angle. The field of view is just a rough phrase for the visible area. It doesn't refer to any mathematical measurement or anything like that. It's just what you can see through the camera at that point. Here's a couple of examples for you. The viewing angle of this 100 millimeter lens, according to the specs from Canon, is 24 millimeters. So that is this wedge shape right here. That is the angle of view. Now remember, it's a cone because it's a cylinder. So it could be 24 millimeters this way or this way. It's actually in a circle. So that overhead or sideways representation of this angle of view is the same whether you're top down or on the side. Now by comparison, this 24 millimeter lens has an angle of view of 59 degrees. So you can see the number of the millimeters went down, but the angle of view got bigger. So why is that? To understand, let's go to the next slide. The viewing angle and focal length has an inverse relationship. The lower millimeters has a wider viewing angle. And the reason why is because it has to do with the distance from the glass to the sensor. So you can see in this representation, you might remember this from Camera Basics, the 24 millimeter circle is 24 millimeters away from the sensor plane, and then the 50 millimeter circle is 50 millimeters away from the sensor plane. So this circle gets further away, thereby narrowing the field of view. And it's basically like if you were to make a circle, like an OK sign with your fingers, and you look through it with your eye. Bring it nice and close and you can see really wide. The further away you go, the smaller the field of view gets. Now this is why zoom lenses get longer as you zoom them out. And as a representation, we can take this Canon 24-70, and as I start at 24 millimeter and I zoom it to 70, you can see that the lens actually physically gets longer. Now, why is that? Because as I zoom to 70 millimeters, it actually has to go out to 70 millimeters. Now that construction is all hidden inside the barrel of the lens. So as I zoom back, it retracts and then brings it closer, thereby widening the field of view. Now, some lenses are going to have an internal zooming design, like this Canon 70-200. When I'm at 70 millimeters, you can see how long it is, and then I zoom to 200 millimeters and it doesn't change. And the reason why is because everything is held inside the housing. As you zoom, the lens elements are sliding forward and backward, but nothing changes on the outside. And this is for durability purposes and for weather sealing and protection and things like that. You have a little less protection when it actually protrudes like that. When the lens is all internally housed, it's much more durable. Now, it's much more common to find lenses that have an externally zooming design. Here's another one. It's the Tamron 28-75. You can see that it protrudes a bit. okay? And that is much more common. You're gonna find that to be the case. Internally zooming lenses are gonna be much rarer and much more expensive. Now let's get into a few image representations of what the different focal lengths are gonna look like. Now, the general characteristic of a wide-angle lens is that it's going to have a bit of lens distortion. There's going to be a little bit of a bending because it's showing such a wide field of view. Sometimes less expensive lenses are going to have curvature or some distortion that's going to be present in the images. Very expensive wide-angle lenses, not necessarily expensive, maybe very optically perfect lenses are going to have little to no lens distortion present in the image. For example, this Zeiss 21mm lens is a very wide-angle lens, but does not exhibit a lot of bending and curvature and distortion in the images. Now, it is an expensive lens. It's well over $1,000. So you are paying for that feature. In a moment, we're going to jump into looking at the images full screen, but this is my young model, Petra, who volunteered to help me out with this lesson. And I used four different lenses to photograph these images, but these are the two main ones. And the reason why is because one is full frame and one is a cropped APS-C size sensor. So I shot one series of images with my Fujifilm X-T3 and my 16 to 55 f2.8 zoom lens. Then the other series I shot on my Sony a7R II, which is a full frame camera, and I used an adapter for my Canon 24 to 70 zoom lens. Now, my method for shooting these photographs was that I shot a frame at each of the main focal length markers on the lens. So you might be able to see on the lens, there's writing here, and those are markers for the primary focal lengths. So 16, 23, 35, and 55. And then on my full frame lens, I have 24, 35, 50, and 70. So if you were to do the math and multiply, if you remember from camera basics, the APS-C sensor is a 1.5 magnifier. So 16 is going to be roughly 24 millimeters. 23 is going to be roughly 35. 35 is going to be roughly 50 millimeters. And I say roughly because it's hard to be exact. Each of the sensors has some slight, tenths of a millimeter difference here and there, okay? So after I shot an image at each of the main focal lengths, I then shot another series where I moved myself back and zoomed in to keep my subject the same size in the frame. So you can see that throughout these images, she is about the same size within the frame, and that's because I moved back as I zoomed in. So I was kind of using, a rule of thumb to keep her the same size in the frame. I wasn't exact because, I didn't have number markings within the frame or a tape measure or ruler enabled to make sure, I have exactly 18 inches across the frame or something like that. What I can point your attention to in these images is to observe the separation from the background and the distortion amount that's present in the images. So in the left image, you can see that there actually is a little bit of distortion where it's kind of elongating the body. When you go over to the longer focal length, you can see how separated she is from the background. Whereas in the left frame, you can see that you can still make out the background. There's still a little bit of a crispness and focus to the background in the wider angle. When I back up and zoom in, you can see that there's a much nicer focus fall off where the background becomes very softly out of focus and it's very attractive. Here's a close-up of the lens that I was just showing you a few minutes ago, and you can see the main focal length markers on there, 24, 35, 50, and 70. Okay, let's jump into Capture One real quick so I can show you a few image examples. What I did was I started back from the house a bit and shot at the widest angle view that I had, which is 16 millimeters on my Fuji camera. And you can tell it's a Fuji because it's got a .RAF suffix at the end, and over here in the metadata panel, you can see that it says Fujifilm X-T3. So if you want to look over there while I'm showing the examples, you can always see what my camera settings were. So starting out with 16 millimeters, which is about a 24 millimeter equivalent in full frame. Then to the next image was 22 millimeters. Now remember, I was shooting for trying to get the main focal length numbers on my lens, but when you're zooming this way or that, you may be off 1 millimeter or another. That doesn't really matter, you're close enough. So here I'm at 22 millimeters, which is a roughly 35 millimeter equivalent for full frame. And then to 34.2, close enough, I was trying to get 35. And that's a roughly 50 millimeter focal length in full frame. And then to 55, which is about an 85 millimeter full frame equivalent. And I kind of had an oversight here. I really should have aimed for a 70 millimeter equivalent, which would have been about 50 millimeters, or just under 50. It would have been about 47 millimeters, which there is no marker for that, so I would have had to keep shooting and then jumping into my my info panel in the camera to try to see if I had gotten it right. Yeah, so I had a little bit of an oversight there, so I just went to the maximum, which is 55, and that's about an 85 millimeter focal length on full frame. Then what I did was I added my, I went to my telephoto zoom lens, my 55 to 200, and carried on from there. So now here is a 70 millimeter frame. Here is a close to almost a 100 millimeter frame. Here's a 135 and a 190. So it looks like I thought I was at the end, but I wasn't exactly. So we'll call that 200. Then I switched over to my full frame camera, my A7R Mark II, and I put my full frame lens on and I shot at 24 millimeters. Then I went to 35, then to 50, then to 70, and then I went to my 70 to 200 and I shot another frame at 70 millimeters. Now this is interesting because look at the difference between my 24 to 70 at 70 millimeters and my 70 to 200 at 70 millimeters. And you say that the 70 to 200 at 70 is actually much closer, but there's a good reason for that. The 70 to 200 is actually a much longer lens than the 24 to 70. So it's as if I actually took a step closer. It's a good, 3 or 4 inches longer, meaning that it's physically closer to the subject. So that's going to have a magnification effect on your photograph. So then here's the 70 to 200 at 100, and then 135 and 200. Okay, now I want to show you the equivalent field of view for some of these shots. So you can see if we go to, let's say we grab this 16 millimeter from the crop sensor camera, and then we go to the 24 millimeter on the full frame. Now, other than the framing being off just slightly, so at the bottom, you can see that there's more grass here, and up here, there's more sky. So it looks like my framing was off just slightly. So they have a very, very equivalent field of view. You can see the width is very close. It goes from the garage door to the middle of the window here. Same, middle of the window to the garage door. So they are very, very similar. And that is 16 millimeters and 24 millimeters, okay? Then let's go to the 22 millimeter, or supposed to be 23, which is roughly a 35. So we go to this image, and you can see that they have a very similar field of view once again. So a 23 millimeter crop sensor lens is going to be equivalent to a 35 millimeter full frame. We can do it again with the 50 millimeter, and that's going to be the 35 on the left and the 50 millimeter on the right. So the crop sensor 35 is going to be equivalent to the 50 millimeter on the right, the 50 millimeter full frame. So I think you're getting the point here. Now, if we were to compare the same focal length, so if we were to get the 70.5 here and compare that to, yeah, so the one on the right is the 70 millimeter full frame. The one on the left is 70 millimeter crop sensor. So you can see how much larger in frame she is as compared to the right. So that 70 millimeter on the right is actually more equivalent to that 100 millimeter from the full frame. Let's take that one. That's a 135, which is going to be equivalent to close to a 200 on full frame. And I want you to see the difference between full frame. So there you go, you have a 135 on the left, which is the crop sensor, and then you have a 200 millimeter on the right, which is the full frame. Now observe the difference in the background separation, how much softer the background focus is as compared to the crispness of the background in the crop sensor image. So there's definitely not only a difference in the way the crop sensor camera renders the images, but there's also going to be a difference in the equivalent field of view background separation. Full frame cameras are just going to do a better job of separating the background. Now let's talk about lens distortion. Here is the 16 millimeter up close. So remember, the first 16 millimeter I shot was this one far away. You can see how much closer I had to get in order to get where is it? To get that image. So the next part of the what is eventually going to be your assignment is to start close and fill the frame with your subject, and then I want you to take the same range of images and focal lengths, but I want you to back up and keep your subject the same size. So I'm going to go from 16 millimeter, 22 or 23 millimeter, to 35, to 55, okay, and then close to 70, and then about 100, 135, and 200. So if I were to highlight all of these images, you'd be able to see the progression of that lens distortion going from very distorted to no distortion. Now, if you start here, that distortion kind of disappears from 16 to 23 to 35. It's pretty much gone. It's even kind of hard to see in this image if you didn't see it right next to the other one. So that 16 millimeter on the left and the 23 millimeter in the middle do have lens distortion present. But the 23 millimeter is pretty low. It's basically gone by the 35. The 35 millimeter is going to give you a very accurate representation with straight lines and low distortion, but it's not giving you any background separation. When you go on further and you start to add these images, now the background separation is going to get a little bit more dramatic, and by the time you get to the 200 millimeter or say 135 and above, there's going to be quite a lot of separation. So let's compare. Let's just do sort of like the beginning and end of the range. So you can see that one on the left, that's 128 millimeters. Now there you go. That's a big difference. That's going to be 35 on the left, which is equivalent to 50 millimeter full frame, and 200 millimeters on the right. So you can see I did have to get back quite far, because you remember from that other image where I shot all the photos from the same place, how far away I was when I shot that 200 millimeter image. So now let's go over to the full frame examples just to show you the difference. The 24 millimeter, let's start with that one, and you can see the dramatic lens distortion present. It's almost kind of silly, which can be used to a useful dramatic effect. There's a lot of foreshortening where the center of the face is drawn closer to the camera, or the ears and the back of the head are pushed back. So there's quite a dramatic distortion going on. Then let's go to 35. So 24 to 35, there's a huge difference between that. You can see even in the shape of the background door and the flowers, the way that it's the 24 has a lot more of the flowers present, whereas the 35, they are separated nicely from the background. And then to the 50, you can see that the background flowers are separating even more, and they're becoming softly out of focus and really pretty background elements. Then we get to 70 millimeter, right? And there's a difference there. 70 millimeter, then to 100 millimeter, right? And you can see the difference again to 135 to 200. Okay, so if we quickly go through that range, starting from here, you can see it kind of creates a funny zoom effect. If we go to the end of the range, look at these two flowers right here and how they separate in the wide angle shot, right? They're in the same relative position. It's just that the attention drawn to them is much less in the wide angle shot. Actually, going back here, we go back to the widest angle and they almost disappear behind because I have to get so close to her that I can't even see them anymore. Okay, so starting from here, 1, 2, 3, 4, 5, 6, you can see how large they are actually because the relative distance to the face has actually gotten smaller as I get further away. When I'm very close to her, those flowers are actually pretty far away. Then I back up and those flowers get actually, relatively speaking, closer to her because I'm further away. That might be kind of confusing, but it's going to make sense to you once you start to do this practice assignment. Then one other effect, just to kind of demonstrate the foreshortening effect that happens with wide-angle lenses, I had Petra use a flute here, and then I got really close to the flute, so you can see how long it looks in comparison. So we all know flutes are not that long. You know, they're between 12 and 14 inches long. This is just a child's plastic toy flute. It's really not that big. And I am, actually it's a recorder, sorry. So I'm actually really, really close to the recorder. And then as I do the same experiment with focal length going out to 70, you can see the difference from 24 to 35 is the most dramatic. And then to 50, now you can see the accurate representation of the size. Okay, and then to 70, 50 and 70 don't really have that big of a difference. But there's a difference between 50 and 35, and there's certainly a difference between 24 and 35, right? So if I put all these on the screen, you can see the relative length, how that recorder takes up in the 24 millimeter shot. It takes up like 40% of the whole frame, maybe even more than that. Maybe it's 50% of the whole height of the frame. But by the time you get to the 75 millimeter shot, you can see that the relative size is only about the size of her head. So it's really shrunk in comparison. So that is an example of lens distortion and how it can dramatically increase the size of the objects close to the lens. Okay, so let's get to your assignment. This one should be fun because you're going to be experimenting and checking out the differences in what your equipment is able to produce. So the most important part of this assignment is that it's going to require a zoom lens, which most, if not almost all of you are going to have. Almost all cameras now come with a kit zoom lens, or whenever someone gifts a camera to somebody else, they include a zoom lens with it because that's what came with it. So just about everybody watching this is going to have a zoom lens. If you don't have one, see if you can borrow one from someone else because it's going to be very useful in practicing with this assignment. You're going to shoot 2 series of images. The first one, you're going to stay in one spot and zoom your lens to each of the main focal length markers. And then you're going to observe the differences between the images. On the second series of images, you're going to start close to the subject at your widest focal length. And then you're going to back up with each successive shot, trying to keep the size of your subject the same in each frame. Okay, so if I were shooting with this lens and I start at 24, let's say I'm taking a picture of this and I'm about here when I start. I'm going to zoom to 35 and then back up until it's the same size. Then I'm gonna zoom to 50, I'm gonna back up again until it's the same size, and so on, okay? Now, just to give you a little pointer as to exactly what we're talking about, these are the two most common lenses that the majority of you are going to have. This is the Nikon 18-55 kit zoom lens, and this is the Canon 18-55 kit zoom lens. Both of these lenses are extremely common and not very expensive. They're about $200 each. So you are most likely you're going to have one of these lenses. So the markings are present on them. You can see 18, 24, 35, and the Nikon actually has a 45 marker, which is pretty useful, and then 55. The Canon has 18, 24, 35, and then all the way to 55. As I mentioned with my Fuji lens, how there was no marker for roughly, or that 50 millimeter marker, which would give me equivalent to about a 70 millimeter from the 24 to 70. This one actually has, the Nikon actually has a 45 marker, which is going to be about a 70 millimeter. Okay, that's going to do it for this unit on focal lengths. I hope you enjoyed this lesson, and I hope to see you in the next one. Until then, keep shooting.